probably heard the stories from the Mahabharata about Arjuna's incredible chariot, Nandighosha. It was said to be a gift from the gods, totally invincible. But what if it wasn't just magic? What if it was just absolutely brilliant engineering? Today, we're going to put this divine war machine under a modern microscope and see what made it tick.
And this is the big question, isn't it? The ancient texts talk about Nandighosha withstanding weapons, these things called astras, that had the power of 10,000 suns. I mean, you see this massive explosion erupt. The shockwave hits, the chariot gets rattled, for sure, but it doesn't break. It just keeps going. How? Was it purely divine protection, or was there something else at play here?
All right, so to even begin to unpack that, we've got to start with the most immediate, the most violent threat from any explosion, the physical blast wave. This is our first stop on this little engineering teardown.
You know, when you think of an explosion, you probably picture the big, fiery ball, right? But for a vehicle, the real killer isn't the heat, it's the kinetic shockwave. It's this invisible, unstoppable wall of pressure that moves faster than the speed of sound. It can rip solid steel apart. So for a chariot made mostly of wood, well, that should have been game over, instantly.
So how in the world could it have survived that? Well, today's military vehicles use things like hardened composite armor and V-shaped hulls, all designed to deflect that blast energy away from the vehicle. But the theory behind Nandighosha's design suggests it did almost the opposite. Instead of a rigid frame that would just shatter under that much force, it might have had a flexible interlocking structure. Think of it less like a solid box and more like a woven basket. It was designed to bend and flex, absorbing that kinetic energy and spreading it throughout its entire body, kind of like how a modern race car is designed to crumple in very specific ways to protect the driver inside. Okay, so surviving the initial impact is one thing, but what about not getting tossed 100 feet through the air? That brings us to what might be the most ingenious, most mind-blowing part of this whole design, its stabilization system. And to get our heads around this, we actually need to look at modern skyscrapers. There's this incredible piece of engineering called a tuned mass damper. The idea is actually pretty simple. If you have a super tall building, wind and earthquakes can make it sway dangerously. So what do? You hang a massive, heavy weight near the top. When the building sways one way, the pendulum swings the other way, basically canceling out the motion and keeping the whole thing stable. And here is where it gets absolutely wild. Look at this. On the left, you've got the tuned mass damper in the Type A 101 skyscraper. On the right, Nandighosha. The ancient texts say that Lord Hanuman sat on the chariot's flag mast specifically to keep it stable. From a pure engineering standpoint, placing a huge amount of mass high up on a mast is the exact same principle as a tuned mass damper. So as that shockwave from an astra hits the chariot and tries to flip it, Hanuman's mass up there on the flagpole would swing against the force, keeping the wheels planted firmly on the ground. It's basically a divine active suspension system. Incredible. So we've got a frame that can absorb a blast and a stabilizer to keep it grounded. But you know, the best hardware in the world is just a fancy paperweight without the right software to run it. This brings us to the chariot's control system. And this just says it all, really. You can have the most advanced, most perfect machine ever built, but it's really nothing without someone or something at the controls that can push it to its absolute limits. And for Nandighosha, that driver was Lord Krishna. But see, Krishna wasn't just a driver. Think of him more like the chariot's central processing unit, its tactical AI. He was reading the entire battlefield in real time, predicting the ballistic paths of incoming weapons, and executing these constant, tiny micro-adjustments. You can almost imagine the reins glowing with data as he's steering the chariot, not just away from the blast, but into the precise pockets of space where the shockwave's impact would be the weakest. This isn't just steering. This is a level of real-time battlefield navigation that is, well, divine. So when you take a step back and you put all of these pieces together, the frame, the stabilizer, the driver, the whole story of Nandighosha just transforms. The myth of some magical invincibility, it starts to look a lot more like a blueprint for a perfectly engineered combat system. This quote just nails it. Nandighosha wasn't protected by simple magic, it was a masterpiece of vehicle dynamics. The point here isn't to take the magic out of the story, is to suggest that the magic was the engineering. It was a way of describing incredibly advanced principles of physics and vehicle dynamics that we're only now really starting to appreciate with our modern scientific lens. So let's just recap it one last time. The three pillars that made this machine a legend. Number 1, a kinetic absorbing frame that could withstand the initial blast. Number 2, a divine-tuned mass damper on the flag mast that gave it unbelievable stability. And number 3, a real-time control system that could navigate the battlefield perfectly. You know, any one of those systems is incredible on its own. All three working together in harmony, that's how you engineer a legend. And that's the thought I really want to leave you with. If we can find the principles of modern mechanical engineering hidden inside the story of a divine chariot, what other technological marvels are hiding in plain sight in our oldest myths, just waiting for us to find the right scientific key to unlock them?